right, here we go. This is number 1 from the study guide. We are looking for a vertex, axis of symmetry, and the zeros of the following quadratic function. So to find the vertex, we're following the formula, which is the negative b divided by 2a. And once we find that, we plug that number into the function to get the output of that vertex point, f of that. So I got our a to be negative 4 here. Our b is positive 4. Let's plug it into the equation here. So it's negative 4 divided by 2 times a, which is negative 4. That's giving me negative 4 over negative 8, which is positive 1/2. So that's the first part of that point, a half. To get the output, we're going to plug in a half into the equation, or 0.5. And for x here, all right, so we got a half squared is a fourth. So negative 4 times a fourth. Half of 4 is 2. 1/4 times negative 4, that comes out to be negative 1 plus 2, which is positive 1. So the output for my vertex point is 1. So my vertex is 1/2, comma 1. My axis of symmetry is the x part of the point. Axis of symmetry is x equals negative b over 2a. We figured that out from the beginning. So that is x equals a half. To get the zeros for this quadratic function, well, to get the zeros, I'm going to factor it. So let's make this equation equal to 0. This is not a trinomial. This is definitely GCF factoring. So I'm going to pull out a negative 4 and an x. And I'm left with, when I divide negative 4x into a negative 4x squared, I'm left with x. And then minus 1, right? Because negative 4x into positive 4x is a negative 1 equals 0. And then I make each of these things equal to 0. So one of my zeros is positive 1. The other one is 0. So my zeros are 0 and 1. That's for number 1. All right, taking a look at number 2 here. We are finding the vertex form of the following quadratic equation. So look in your notes for vertex form, which is this: a times x minus h squared plus k. The h and the k is the vertex. We need to figure out what the a is by plugging in a random point on the graph there. So let's see if we can find the vertex first, which is this low point down here. That looks like it's at 1, comma, negative 3. That's my h and my k. And now we could choose any other random red dot there. That would make sense. I'm not going to choose the ones on the x-axis because that's some kind of decimal value. So I am going to choose this one right here. And what is that specific point? It's 0, comma, negative 2. So that's what I'm going to plug in for my x and my y. So I have these 4 numbers to plug in the equation here. Remember, f of x is y. So this is going to say negative 2 equals, we don't know what a is. Our x is 0 minus our h is 1. And our k is negative 3. Let's work out the inside here. So I got this to be negative 1 squared plus negative 3. That makes it positive 1a, or just a, plus a negative 3. Let's add the 3 over. So my a is 1. So what is my vertex form of the equation? I'm going to rewrite that equation. The a is 1, so I don't even need it. X minus 1 squared, and then plus a negative 3. So this is my vertex form of the following graph. Number 3, we're looking for the zeros, their multiplicity, crossing or balancing, the degree, the end behavior, and sketch the graph. All right, so this is already factored out. So I got my zeros to be 2. So let's put that in our chart here. So in our chart, The 0 here is 2. What is its multiplicity? Its multiplicity is with the power here. Its multiplicity is 2. And when the multiplicity is even, that means it's going to bounce. The other one, 0, is positive 3. That multiplicity also is with the power, is 2. That means it's going to bounce. Again, if it's an odd power, it would cross. The total degree is adding up your multiplicities here, which is 4. And then you need to look at the chart that we did together as a class. If you have an odd degree, if you have an even degree and it's positive, your end behavior, your tails are both going up and up. So when I come up to my graph here, let's plot my 2 zeros. One is at 2, one is at 3. My tails are going to both be going up and up like this. So this is kind of close. So when I go down to 2, I'm going to bounce off. And I'm also going to bounce off the 3 back up. So that's what your graph looks like for number 3. All right, we have another one for number 4. Find the zeros, their multiplicity. Okay, so we have an x squared. So that makes one of the zeros as 0. So let's put that in the chart here. Whoops. Let's see, can I move this up? Yes, a little bit more. Okay, so that one is 0. Oops. The multiplicity, again, is the power. Okay, so I got 0. Its multiplicity is 2. It's going to bounce. Okay, the other one here, let's write them both down, x plus 4 and x minus 3 squared. X plus 4. All right, so for this one, so this 0 is negative 4. What is the multiplicity for this one? Well, it's the imaginary 1 here. So this multiplicity is 1, so that means it's going to cross. For x minus 3, we add the 3, so we have a 0 as 3. Its multiplicity is the power, which is the 2. That means it's going to bounce. The total degree for this one, add up your multiplicities, is 5. So you have an odd degree power, and then if I go ahead and look up at the beginning here, take a look, it's got a negative. So if it's a negative and it's an odd power, look at your chart, what would the tails look like? Oops. Up and down, right? All right, so if we go back up and plot, let's see, it's going to be up and down. Let's plot the zeros first. We got it at negative 4. 1, 2, 3, 4. 1 at 0 and 1 at 3. Tails is going to be up and then down. So when we go to negative 4, it says we're going to cross. When we go to 0, it says we're going to bounce. And then when it says when we go to 3, we're also going to bounce off of it. So that's what it should look like, the graph for number 4. Okay, for number 5, we're looking for asymptotes. All right, so let's talk about our vertical asymptotes. Vertical asymptotes, you're only looking at your denominator. And we would have to go ahead and solve for this. So this denominator is x squared minus 25. Make it equal to 0. Solve it for x. So I have 2 possible x-intercepts here because the square root could have a positive 5 and a negative 5. So I have 2 vertical asymptotes at 5 and negative 5. Horizontal asymptotes, you are looking at the degree, right, of numerator and denominator. So those are those cases that we had written down. So the degree of the top is 1. The degree of the bottom is 2. So if the bottom is bigger, that's the easy one. That's y equals 0. All right, moving on to number 6, same thing, finding the asymptotes. So let's find the vertical asymptotes first. So we make the bottom equal to 0, solve it. So it has one vertical asymptote, x equals -2. Horizontal, we're looking at the degree, right? So the degree of the top is 2, the degree of the bottom is 1. That means I need to do some division here. So I'm going to do synthetic division. So this is actually an oblique asymptote because the top is bigger than the bottom. So let's go ahead and set up our synthetic division here. On the outside is going to be -2 because I have to make x plus 2 equal to 0 and solve it. On the inside, let's put our coefficients. The coefficient for x squared is 1, then 8, and then 9. Let's start our process. Bring down the 1, multiply, add, multiply, and add. This is my remainder. That is not my asymptote. My asymptote is this 1 and this 6, but I need to write it as a polynomial. Since we started with x squared, this is going to be a 1x plus 6. So that is my oblique asymptote there for number 6. Number 7, again, we were looking at our vertical asymptotes first, so that's looking at our denominator. So let's make this equal to 0 and solve this for x. So I got it to be -5x equals -3. Divide by -5. So my vertical asymptote is positive 3/5. X equals 3/5. All right, now let's take a look at our horizontal. We're looking at the degrees. So the degree of this one is a 1. The degree of this one is also a 1. So they are equal. So when they're equal, we have to divide by those coefficients. All right, so what are the two coefficients of those two? X to the first, we got a 2, and we have a -5 on the bottom. So I'm looking at this one and this one. I divide it. I can leave it as a fraction. I mean, if you want to put it as a decimal, you can. But it's 2 over -5 is my horizontal asymptote for 7. All right, number 8. We're forming a polynomial. So I'm going backwards of degree 5. Where the zeros are, so the zeros, we got a 0 to be a -3, so that means backwards it must have been x plus 3. Its multiplicity is 2, so let's put a 2 there. The other 0 is a 6, so going backwards it was x minus 6. Its multiplicity is 3, so let's put the power of 3 with that one. And is it a degree 5? Yes, it is, because if I add those two up, I get 5. So that is my answer for number 8. That's the polynomial. All right, number 9. Is x plus 5 a factor of this polynomial? It says use polynomial division or factor theorem. What was the factor theorem again? It was plugging in my value of that x plus 5. So I'm going to plug in to my function -5. That's what I'm dividing by. And if I get an output of 0, that means it's a factor. So I'm using my calculator and I'm plugging in -5. Now I have to get my calculator. Let's see here. I got my -5 raised to the 3rd. Okay, that gives me a -125. Then I have a -2 times that, which is positive 25, right? Let's see, 17 times 5 is 85, positive 85. Okay, let's work this out. Subtracting 50 plus 85 minus 10. So when I put this in the calculator, let's see what happens. I get a remainder of -100. So that means it's not a factor. If I wanted to do the polynomial division, let's practice that so we can all take a look at that one. So if I set it up, I put in my coefficients 1, -2, -17, and -10. On the outside is -5. And then I do my synthetic division, bring down the 1, multiply. get -5, add -7, multiply 35, -17 plus 35 is 18. 18 times 5 times -5 is -90. Add those up, you get -100. The same answer that I got here. So definitely not a factor. All right, moving on to number 10. This one here is dividing, long division. All right, so let's set up our house. It looks like we have everything, so I don't need a placeholder here. I have from x to the 4th, to the 3rd, to the 2nd, the x1, and the constant at the end. And on the outside is 2x minus 3. All right, we're starting the process. 2x times what is going to give me 2x to the 4th. I definitely need 3 x's, so that's x cubed. And then somewhere on the side, you could multiply x cubed times the 2x minus 3. That helps you out. And that gives me 2x to the 4th minus 3x cubed. So I'm going to write that underneath in the like term areas under those, right there and right here. I'm going to put that in parentheses because what are we doing? We are subtracting them. So the 2x to the 4th minus that one cancels. Be careful now for this one. It's a -9 minus a -3, which is -6x cubed. Everything else comes down. And I'm going to restart the whole process again. So again, I'm looking at 2x into -6x cubed. So what would I need for that? I would need a -3. And how many x's would I need? I would need x squared to give me that x cubed. So now on the side here, I'm doing -3x squared times 2x minus 3. Go ahead and multiply those out. -6x cubed plus 9x squared. That's what is going to go under here. And again, I am subtracting, so be careful. So a -6 minus a -6 to cancel. 21 minus 9, that is 10, 11, that would be 12, was 21. 21 minus 9 is 12, that was right. 12x squared. Bringing down this one and the other. Okay, I'm starting the process all over again. 2x into 12x squared. That I need a 6, positive 6, and another x. And on the outside, I'm going to do 6x times now the 2x minus 3. Multiply that out. I get 12x squared minus 18x. I'm going to put that underneath the like terms here. Put it in parentheses with subtraction. 12 minus 12 cancels. -26 minus -18 is -8x. Bring down the plus 12. One more time again. 2x now into -8x. So I need a -4. So I'm doing -4 times 2x minus 3. That becomes a -8x, positive 12. Putting that in the spot there. Again, these are being subtracted. These all come out to be 0 as a remainder. So my answer here is this big thing on the top. X cubed minus 3x squared plus 6x minus 4. Okay, number 11. I am trying to figure out the zeros of this function using the rational zero theorem. So let's talk about that one. That one's finding your p. P is the number at the very end, the constant. Here it's 20. I want the factors of 20, so I could have 1 and 20. Oops. I could have 5 and 4. I could have 2 and 10. What else can I have? 4, 5, 6, 7. I think that's it. Then I'm looking for my Q number, which is the one that's in the leading coefficient, which is the imaginary 1. So that's just plus minus 1. So if I take all my p's and divide it by q, which is 1, I'm basically going to get all of these back. So all of these are the p divided by q. So I said now to go ahead and graph this on your calculator or on Desmos. You could do to see which of these actually work. So I'm going to do this right now on my calculator. Just give me a minute. And when you graph it on your calculator, you're going to be seeing which zeros do work. I said to choose one of the zeros that is working there. So I'm going to choose the positive 1 because it's just easier to work with a positive integer. So I'm going to start with 1. It also is crossing at, let's see, at negative 4, looks like, and negative 5 also. All right, so I'm going to check the 0 for 1 first. All right, so how do I check it? I'm going to use my long division here. All right, so I'm going to make my thing, put my coefficients. I'm going to check that the 0 of 1 works. I'm going to bring down this one. 1 times 1 is 1. 8 plus 1 is 9. 9 times 1 is 9. Add those up, you get 20. Add the multiply, you get positive 20. And 0 is the remainder there. So one of my 1, 0 does work because I got a remainder of 0. So what's left here? We go 1 less, so this is going to be x squared plus 9x plus 20. So x minus 1 is one of the zeros that works, right? And then how are they getting negative 4, negative 5? Okay, and they get negative 4, negative 5 because if I factor this, factors of 20 that add up to 9 are 5 and 4. So this is my other factored part of the form. I believe the question is just asking for, what is it asking for? Find the zeros. So we found the zeros. It was 1, negative 4, negative 5. You had to at least show me which of the zeros that easily is for you to synthetically divide that it does work there. But these are the ones that do work. All right, moving on to the last problem here. We're making a graph of the following rational function. All right, so there was a piece of paper that we did this week, about getting your asymptotes first. So let's get our asymptotes first here. So let's find our vertical. That's looking at the denominator. So my vertical, let's see, is x squared minus 4 equals 0. So I get it to be positive 2 and negative 2 as my two asymptotes. So I'm going to sketch those two in. Positive 2 and negative 2. Okay, what's my horizontal asymptote? Let's take a look at the degrees. So the degree of the top is an imaginary 1 there, right? Degree of the bottom is a 2. So the bottom is higher. So that makes your horizontal asymptote y equals 0, which is basically your x-axis here. I'm making it as a dotted line. So I need to choose some test points to the left of that negative 2, in the middle, and to the right. And I'm going to be using the equation and plugging it in to see if the output is positive or negative. So I know the direction that I'm going to be doing it in. So I'm going to choose a negative 3 first, because that's to the left of negative 2. I'm going to plug it in. So just be careful. We get 1. This is a positive 9 minus 4, so it's 5. It's a fifth. So that means when I plot this point, negative 3 comma a fifth, it's somewhere above the x-axis, rubbing up against here. It's just an approximation. All right, let's choose now in the middle. Okay, choose, okay, -1, -1 plus 4, -1 squared minus 4. That's 3 over -3, so that's a -1. So I'm going to be plotting -1, -1. So it's down in this area here, right? What is it when it's 0? 0 plus 4, 0 squared minus 4. That's 4 over -4. So that's -1. So 0, -1. So it seems to be in this area here. Okay. Oops. Now let's choose +1. 1 plus 4. 1 squared minus 4. So that's 5. Over 1 minus 4. -3 again. So it's 1 comma -5/3. So the other part of this graph here is, yep, it's in this area down here. Oops, I should do it in, let's do it in the, oh shucks, in the blue. My bad. Sorry. Oh, I did it in red instead. Okay, let's put those asymptotes back. They got erased. Okay, so the graph is going down in this area here. All right, and then we choose a point to the right of 2, so I guess I'll choose 3. And 3 plus 4, 3 squared minus 4, so that's 7, and then 9 minus 4 is 5. So it looks like it's up, yep, positive, 3 comma 7/5. So let's move this back up here. That means it's somewhere, 3 comma 7/5 is 1 point whatever. So it's somewhere around here. So it is up in this area, rubbing along the asymptote. And again, the horizontal one there too. So that's what the graph of the last one looks like. Just got to be really careful with doing test points, just getting the general direction. Is it above or below the asymptotes there?